All right, good morning, guys. This is a video for my students, giving them an introduction to Scatterplots. And we are talking about Scatterplots this week as a finishing up for our graph series type of thing. And what this will lead into is we're actually going to do a project towards the end of this unit, and you guys will be asked to create a scatterplot with some of your own data. So I would say it's very important to pay attention to this video. Let me get that all situated. There we go. All right. So we are going to start off today and we are going to learn some vocabulary for scatterplots and just get moving on it. All right. So like I said, first things first is vocabulary. And so our first thing that we need to talk about is obviously what is a scatterplot? Why do we use it? How are they helpful? What kind of data do they represent? And that kind of thing. So as you guys already know, we have been talking about bivariate versus univariate data, and scatterplots are used to represent our bivariate data. So if you guys need a refresher, that is when we have two variables within our data sets. And so that leads into our two axes here. So as you can see, we've got the x-axis, which is the horizontal axis. And that's just a reminder, you guys should already pretty much know that information. And I know you guys are super smart and ready to go on that one. And y-axis is going to be our vertical. So again, just pay attention to the arrows here. X-axis goes left and right, and y-axis goes up and down. And another quick thing, guys, just feel free to pause this video, replay, take notes on the vocabulary because it'll be super important later down the line, especially when you're making your own scatterplots. So next we're going to get into a couple things that are unique to scatterplots, except this origin should be pretty familiar to you guys, so we'll go over that one first. We'll go a little out of order here. And so our origin is the 0.00. So our x value is 0 and our y value is 0. And you guys know that's where all of our graphs should start. And we'll get into a couple examples later in this video of maybe it doesn't always start there, but it pretty much should be represented in every graph. So then, specific to our scatterplots is the line of best fit, which is a line that's representative of most of the data on your graph. So when you have a graph in front of you and you want to draw a line to maybe show a trend, maybe correlation, which again we'll get into later, but you guys should already be familiar with that term. That line of best fit is going to help us see how the data is essentially showing a correlation. And so that line of best fit is going to be super, super important and should be included in every single graph we do in this unit. So I will talk to you about how to draw a line of best fit when we get into some of these examples later. Our last vocabulary word is correlation, which we talked about a little bit up here with the line of best fit. So correlation is when two values look like they probably have some kind of representation to each or relationship to each other. So let's say, for instance, we have height and arm span. Well, we know we can pretty much say that if you're taller, you're probably going to have wider arms. It would be really weird to see somebody that's like 5'2" with longer arms than somebody that's like 6'2". So this is where correlation comes in. And so we will talk about negative versus positive later, but the really important thing to remember for correlation and something that you might want to put in your notes is that correlation does not equal causation. So just because two variables look like they have some relationship with one another does not mean that that variable, one of them, causes the other variable. All right, moving on from vocab, let's talk about the 5 essential parts of a scatterplot. So right over here on the right-hand side of your screen, I have just an example of a scatterplot. I pulled it off the internet, if we're being honest, and then added some things for myself there. But first thing we want to talk about with a scatterplot is the title. So every single scatterplot that you make needs to have a title. And this one, it's scatterplot of weight versus height. Okay, that's a pretty decent title. It tells us what the graph's going to be about. Then we have X and Y axis labels with units. So let's look at our X axis. Our X axis is labeled height, and our units looks like 60, 62, 64. For this class, I would love it if you guys would remember to put units. So you say like height in inches, or height in feet if you want to do like 2 foot, 3 foot, 4 foot type of thing. And then we have our y-axis, which is weight. Again, I would love it if this said like 100 pounds, 120 pounds, or if it said weight in pounds. So if you don't want to label every single interval here as 100 pounds, 120 pounds, you can just put weight in pounds in that label off to the left. Next, we have start at 0/broken axis. Okay, so this gets into the origin. Here, our graph looks like it starts at about maybe 80 pounds and probably a height of about 60, maybe a 59, but so then we have this little weird squiggly thing here, and I know some of you are probably wondering, well, what the heck, Miss Outlaw, why is there a weird squiggle? Well, that's because our axes do not start at 0. So when we start at the origin, we don't have to draw this weird squiggle because we're starting at 0, 0. But if we want to start somewhere else, for instance, in this thing, it doesn't make sense to have a height of 0 or a weight of 0. So we are starting with 60 and 100 as our first labeled units. So then we have to draw this weird little squiggle that basically just represents, hey, I'm not starting at 0, 0, but it's somewhere back there if we were to expand this graph. Our last element that's super important to scatterplots is going to be that our data is plotted. This seems like a no-brainer, but I don't want to see any graphs with just a white background and no dots on it. So make sure that you are plotting your data points and you're plotting them as accurately as possible. All right, now that we've gotten into the essential parts of scatterplots, we need to talk a little bit about correlation, which again does not mean causation. So that's super important to remember. There are basically two types of correlation, positive and negative. Positive means that both of your variables are increasing. So our x variable across the bottom and our y variable across the side are both going up. And so we get this beautiful little line that is going up our graph from 0, 0 to the opposite corner. Then we have negative correlation. And negative correlation is when our x values are increasing while our y values are decreasing. So our x values are going up, 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 up. We're going to the right, while our y values start high, but then go down as these variables increase. So that's pretty simple. Again, the big thing to remember there is that correlation does not mean causation. Now we're going to get into a few examples, and I'm only going to go through one of these, but feel free on your own time to go through a couple of these examples. It will help you later down the road, especially with that project again. So make sure you go through a couple of these examples. I'll go through this one and then maybe one more. So first things first, we are going to go through our list. So let's look at it. Does this graph have a title? All right, so our title in here looks like it is Scatterplot. Okay, not the greatest title, but it does technically have a title. So we're going to give it like half of a check mark with a little X through the end. Because it has a title, but it's not a great title. Then X and Y axis labels. All right, in lab crack size reading. Okay, in lab crack size reading on both sides. Okay, or in field crack size reading across the side. All right, so our X and Y axes are both labeled. Looks good to me. Do we have even intervals at the bottom? Okay, we have 0, 10, 20, 30. All right, our x-axis looks good. What about our y-axis? 0, 10, 20, 30. All right, y-axis looks good. We can check that one off. Is our starting point at the origin? Okay, so on this graph, it's a little tricky to see, but in between each of these, 0 and 10, we would basically have a 5 here. And so on this, it would be -5 on the other side of 0. So our graph does not start at 0, and it doesn't have our broken axis. So we got to ding them for that one. It does not have a starting point at the origin. Remember, if you're not starting at the origin, you got to add that broken axis. All right, last thing. Do we have our data plotted? Well, it looks like they've got a lot of little tiny X's on here, so it looks like they plotted their data correctly. Now, if you want some good practice, I would also recommend using what we talked about earlier, our line of best fit. Where about do you think we would draw a line so that it represents the data correctly? I'm going to use this ruler to figure out how we could draw our data here. So then, does it look like it would go this way? No, probably not. So here. Let's take a red this time. I think it would probably go the other way. This probably has a positive correlation. Your line of best fit should typically be straight. This one's not super straight, but looks like it's a positive trend. So we drew our line of best fit. And again, there's a couple other examples on here, and it asks you to list what is wrong with the scatter plot. So like this one doesn't have a title and it's missing a couple other things, and I'll leave those for you guys for practice. This one I do want to talk about real quick because it doesn't really look like it has positive correlation going up and down this way. Also doesn't really look like it has negative correlation going up and down this way. So what do we do with that kind of graph? Well, this kind of graph we would decide has no correlation. It is possible to have a graph that's not correlated. So let's say that this x-axis was the number of tardies you have per month. And this y-axis is, let's say, the number of minutes a week that you watch TV. Well, we wouldn't necessarily expect those two variables to be related, so this graph probably has no correlation. All right, again, you guys can finish up those last few examples if you want for some extra practice, but otherwise, we are done with this presentation. Feel free to watch it a couple times if you need to. Make sure to get those vocab cards written, or those vocab terms written down. And I recorded this with PowerPoint with Screencast-O-Matic. You guys are welcome to do the same later down the road when we work on that project, which I'll be telling you guys about in just about a week.